So now let's talk about the stability window. We have mentioned the K parameter before, but the ledger and the consensus use a different mechanism for considering stability. That the Ouroboros-Prous paper, the Ouroboros-Prous protocol, provides certain guarantees and of stability that in any given window of 3 times K, 3 times the security parameter, over F, the active slot coefficient, we are guaranteed to always have at least K blocks. And this is what Ledger, the Ledger uses for its stability considerations. Now, and in the next parameter, which is the randomness stabilization window, it was originally intended for something similar to the one above, and it was originally intended for freezing the candidate nonce for the next epoch. But right now, it is used in a different way. It is used just for setting the waiting period for creating the next reward update. Now, let's try to move on to the stake address deposits. So for anyone of us that is not running a stake pool, even for those that are running a stake pool, they need stake keys, a key pair that controls the stake. So that gives the right to participate in the protocol with their stake, either by producing blocks themselves or by delegating. So for doing that, before we can actually delegate or produce blocks, we need to register our stake credentials to the chain. We have to register our stake address to the chain, basically saying, hey protocol, can you put me on the list and count my stake in your numbers? And for doing that, we need to put a deposit, and that deposit is of 2 ADA, which we can get back if we unregister our stake credentials. Now, there is a similar parameter that is for stake pools. So it is a stake pool deposit. If you want to create a stake pool, you need to register it, and that registration actually incurs in a deposit, and that deposit is of 500 ADA. And if you think about it, it is a very important parameter because let's say you create the stake pool, and for some reason, for whatever reason, you decide that you are not going to continue with that. So if you not continue with that, that means that, let's say that you just shut down your node, and then you just were elected for a slot leader, and you don't produce the blocks that you were supposed to create, and that affects the chain density. So that's not good. So if you don't want to continue running the pool, that's totally fine. But now you have an incentive to properly retire the stake pool. And when you retire, you are taken out of the equation on the slot leader election, and then you can get your 500 ADA deposit back. Now we have the stake pool target number, and this is the optimal number of saturated stake pools, and right now it is set to 500. If you divide the total active stake in the system by the optimal number of saturated stake pools, like 35 billion ADA divided by 500, it gives you roughly exactly 70 million. So that means that the saturation point is 70 million ADA delegated to a single stake pool. So any stake pool that controls 70 million ADA is considered to be saturated. And any additional delegation that comes to it doesn't have any additional impact. In reality, that what happens is that rewards keep growing until you reach the saturation point. But when you reach the saturation point, doesn't matter how much additional stake you get, rewards no longer continue to grow. That means that this is like a mechanism to incentivize delegators to actually move to a different stake pool that can actually give them more rewards. So then we have the decentralization parameter. The decentralization parameter was very important in the transition from Biden to Shelley. So after the Shelley hard fork, we want to go to a decentralized block production. But if you think about it, it was a little bit risky to go from a federated mode to a completely distributed mode in 1 second. It was a little bit risky and it was not really desirable. So we created this decentralization parameter that allowed us to slowly transition from a full centralization to a complete decentralization. So right now this parameter is completely deprecated. It is put out of service because we have in Babbage, in the latest hard fork, in the Basel hard fork, we removed the overlay schedule, we removed the decentralization parameter. That means that Cardano can no longer go back to a federated mode. We cannot change the decentralization parameter anymore because this no longer exists. And let me move on to slots per CAS period. This is a very nice protocol parameter that is closely related, as you might expect, to the max CAS evolution. So when you create a stake pool, you need to create a number of keys. We will, later in the course, we will see how to create a stake pool and you will learn all about it. But for now, let's just know that you have to create a number of keys. Some of those keys are called the cold keys, cold like freezing cold, right? And this received this name because they are supposed to be in cold storage. That means that it is air-gapped machine. This machine, it's in a machine that has no internet access whatsoever. And these keys are very important because they control your stake pool. But then, how will you create blocks if your keys are inside of a black box that is freezing cold? Well, we have this other set of keys, which is the key evolving signature, the CAS keys, that is tied together, tied with the cold keys via what is called an operational certificate. And I authorize these CAS keys to produce blocks for this stake pool. And these key evolving signatures are very powerful because it is a signing key, but has a particular property. This signing key evolves, is updated every certain time. And because it is updated, that means that if for whatever bad luck, bad practices or whatever, if these keys get compromised, the adversary can only try to alter whatever these signing keys produced in the latest evolution. Since the latest evolution, everything that happened before the latest evolution can no longer change. This, how often these keys evolve? Well, they evolve every 129,600 slots, and they can no longer evolve. They cannot evolve forever. They have a limited time of evolutions. After that they get useless, and that is what the next parameter is about. The max CAS evolution is set to 62. So your keys need to evolve up to 62 times. After that, you need to renew the keys. And for that, you will need to create another operational certificate and register that again in the chain. It is just a very simple transaction. And that is what this parameter is about. So now we move to the pool retire max epoch. We before talk about the scenario where you wanted to retire your stake pool. Well, if you want to do that, you need to tell the system at what epoch you are planning to retire your stake pool. So when are we going to take you out from the slot leader election process? But it cannot be too much in the future, too long in the future, it can only be up to 18 epochs in the future. And let me just now move on to the minimum pool cost, since we are talking things related to stake pools. Well, this is another nice parameter, and this parameter has been under a little bit of discussions, and I'm not sure what will happen with this one. But the real thing is that it is currently set to 340 ADA, and this is the minimum pool cost per epoch. And as I said, it is a little bit under scrutiny right now, and it's totally fine. Parameters are there. If they are not working or they are not serving the purpose, it's totally fine to have them revised. Now let's move on to maximum transaction size. This is a parameter that has been there for long time, since the Byron era, and it is, as the name says, it is the maximum transaction size in bytes, and currently it is set to 16K roughly. And similarly, we have max blocks body size. So it is the maximum size of a block in bytes, and it is currently set to 90K. If you take a look, however, into the Shelley Genesis file, you will see that transaction size, the block size, sorry, has changed. Before it was set to 65K. Now it is 90. That means that this parameter has been subject of an update proposal. It has been updated to a new value, and it's been raised. So that's great. Now we have evidence that this can be done, and this has happened. Max block header size. So every block has a header. That is the first thing that a downstream node will ask for. Can you pass me that header? And well, this has to be very small so that it can be inspected quickly and transferred quickly. And it is maximum size is of 1100 bytes. And similarly, we have another parameter that is very important, that is the max value size. So it says the maximum serialized length in bytes of a multi-asset value, like a token bundle, in a transaction output. What that means? Well, imagine you have a UTXO, an unspent transaction output. That UTXO contains some ADA and n number of tokens or native assets. Well, once you serialize that, the maximum length of that can be 5,000 bytes. And the reason behind it is that we need to guarantee that whatever UTXO you are allowed to create, then you can later spend it. So we need this is a way to prevent that anyone can suddenly create a UTXO that you can then, that when trying to spend it, you cannot fit it in a transaction. And because it exceeds the transaction size.